As a second example, to learn more lessons in meshing in terms of refinement and stress concentrations, I'd like you to work out a problem of the plate with a hole. A certain plate with dimensions 200 by 150 and a hole of radius 25 is given to you. There is a load P acting on the system, and you can take this load P as 1 kilonewton. So I can write it here, P is equal to 1 kilonewton. The Young's modulus is 70 e to the power 3. And the rest of the information is just the Poisson ratio, which is required for setting up the material type. The reason why we want to do this, despite the fact that we have not gone on to do two-dimensional elements, is because by the time we get to the two-dimensional elements, we'll already be in the last 2 weeks of the course. And I want you to get ahead with a little bit with modeling, because you do have an idea that it's going to be a certain kind of element. It is going to be planar, so we'll be able to only use it in 2 dimensions, etc. are known to you. But there are certain practical difficulties which you also need to be aware of before we finish off with the course, so that you have all the tools necessary at least to work out problems. So I want to look at actually one of the most complicated problems, because then it becomes easier for you to work out simpler ones. Now in this case, there are some things we can already do to make the model more computationally efficient. The first thing would be to reduce this model, as we have discussed before, by using symmetry. So that means I will be only modeling half of this particular plate. So I have half of it, so 100 millimeters in this direction, 150 remains the same, and I will have the whole half of it. It's not really in the center, but well, you understand what I mean. And we also know the load that's acting, and it's not going to change, it'll remain P, and there will be new boundary conditions because of symmetry at this edge all along it. So now you have the new problem that's already defined. Now I can also see that there is another kind of symmetry. So now we have the symmetry about this axis. You also have symmetry about this axis. So I can do a second symmetry operation and get to a quarter of the model, which will only be 100, 75, and this would be, 25 radius with the same load acting on it. Well, I think the load would be pretty high if we use 1 kilonewton per millimeter, but we could keep it just as a representative value. Nothing changes here. So now this would become your final model. Now there we are going to use 2 kinds of elements to model it. One would be 3 node triangular elements and 4 node rectangular elements. You can of course also use a combination of these 2 kind of elements. I can already give you a little hint. Triangular elements are much stiffer. We'll study about them, so we try to avoid using them as compared to rectangular elements. Now over to Abaqus.